Hi, today I'm going to show you these questions. Okay, this question is it's a hard exam type of questions. It containing lots of different knowledge point, including complex number as vectors and also the geometry application of multiplication of the two complex numbers, and also containing roots of unities. So there's a lot of knowledge point combined. So it's pretty complicated and has 4 sub questions in there. So let's have a close look over these questions. Okay, so given that 1 alpha and alpha square are 3 complex numbers on the Argand diagram, as you can see, it's drawn on there, where alpha is the non-real cubical roots of unity. So with the alpha is on the drawing there, if we join that point to the origin, we can see the angle made by the alpha and the x-axis, that angle, and the alpha square, which is also the roots of unity of 1, this angle. So we can see, because the roots of unity is separate the whole Argand diagram equally. So we have 3 roots of unity. One is 1. I'm using different colors. Okay, that's 1. And the 1 is alpha. That's 2. And the 1 is alpha squared. That's 3. So divide the whole circle into 3 equal sections. So then each angle in here would be 2 pi on 3 here, and this angle also 2 pi on 3, but since the negative direction is negative 2 pi on 3. And then of course the rest is another 2 pi on 3. Equally divide the whole circle into 3 sections. Okay, so this is the roots of unity property. Since alpha and alpha square are the roots of unity of 1, including the 1. 1 is also root of unity of 1. So that's what it gives to us. And then we also have Z1, Z2, and Z3. It's the equilateral triangle. So if I join the O to B, the green line here, and also O to A, and also O to C, these 3 green lines representing the vector OB, OA, and OC. And because it's the equilateral triangle and the circle is inscribed into the equilateral triangle, it's like the triangle is the tangent to the circle. So we made a lot of congruent triangle, you can see. So the green line actually divided the 2 pi on 3 into 2 equal parts. So then we can have these 2 angles are equal, so each angle is pi on 3. So this is pi on 3, this is pi on 3. And we have all these pi on 3 everywhere because equally divide pi on 3. And then this is pi on 3, equally divide. And you can see now, so the A and the alpha, they are totally opposite directions and they actually line up a straight line. So the alpha, O, and A are collinear points. So the whole angle alpha OA is 180 degrees, which is pi. So which means the A is opposite of alpha. So Z1 is opposite of alpha. And the Z2, which is B, is opposite of alpha square. And the C, which is Z3, is opposite of 1. They're in the straight line. So these are all the conclusion we have from the drawing here. So I'm going to do the first question now. So first question, proving 1 plus alpha square equals to 0. So I'm going to do it here. Question 1. Okay. So since alpha is the root of unity, which means alpha satisfies this equation if z cubic equals to 1, and alpha satisfies this equation, which means alpha cubic equals to 1. So I'm going to move to one side. Alpha cubic minus 1 equal to 0, and I factorize alpha minus 1. Then we have alpha squared plus alpha plus 1 equal to 0. And since we know the alpha is not equals to 1, because they say alpha is the non-real root of unity, so which is not 1. So therefore, alpha minus 1 is not 0. So therefore, alpha squared plus alpha plus 1 will be equal to 0. So first question done. Second questions. So express the ABC, which is Z1, Z2, Z3 in terms of alpha. So as I discussed before, so the A is opposite of alpha. So will be the totally opposite direction of alpha. That's first one. Second one, the lengthwise. So we can see all the green length is equal and all the red length is equal. But the green length will be double of the red length, since we have pi on 3 for each right angle triangle, and we can do cos pi on 3 equals to 1 on OB, for example. So then we will have OB equals to OA equal to OC equals to 2. So therefore, with the length is doubled, with the direction is opposite. So the first one, A, which is Z1, is opposite of alpha, but the length is doubled. So will be equal to negative 2 alpha. And the B, which is Z2, that would be opposite of alpha squared, so will be negative 2 alpha squared. And the C, Z3, would be equals to negative 2 times 1, because opposite of 1. And the 1 will be same as alpha cubic, which is same as negative 2. So these are the 3 point ABC, which is Z1, Z2, Z3, are expressed in terms of alpha. So that's question 2. Now let's do question 3. So prove Z squared, Z2 plus alpha Z3 plus alpha squared Z1 equal to 0. So let's do the left hand side. So left hand side is equals to Z2, which is negative 2 alpha squared plus alpha times Z3. Z3 is negative 2 alpha cubic, which is negative 2 times 1. Okay, I'm going to change this later on. And then plus alpha squared times Z1, which is negative 2 alpha cubic, because alpha squared times negative 2 alpha become this. So I'm going to simplify this. The first one is still negative 2 alpha squared. Second one will be negative 2 alpha 4. Last one will be negative 2 alpha cubic. So then continue negative 2 alpha squared. Alpha 4 will be equal to alpha 3 times alpha. And alpha 3 is 1 because it's the root of unity, which is 1. So then same as alpha. And alpha 3 is 1, so minus 2. I'm missing the 2 here. Sorry, missing the 2 here. So then become just 2. And I take the negative 2 outside. I will have alpha squared plus alpha plus 1, which I use in the first result. Alpha squared plus alpha plus 1 equal to 0. So then this becomes negative 2 times 0, which is equals to 0. So done. So that's question 3. Question 4. So I'm going to do out here, question 4. So prove the W1 is equals to a third of 1 plus alpha plus Z2 is the roots of unity of negative 1. Okay, so what does that mean? So it means required to prove W1 to the power of 3 equals to 1. Sorry, equal to negative 1. So this is what we need to prove. So let's try. So W1 cubic will be equals to 1 over 27 of 1 plus alpha plus Z2 cubic. So which equals 1 over 27. And 1 plus alpha, Z2 is equals to negative 2 alpha square. And we do the cubic. And from 1 plus alpha square equal to 0, we can tell 1 plus alpha equal to negative alpha square. So I continue using that. It's equals to negative alpha square, negative 2 alpha square to the power of 3. And continue equals to 1 over 27, negative 3 alpha square to the power of 3, which equals 1 over 27 times negative 27 alpha to the 6. Since alpha cubic equal to 1, so alpha 6 will be equals to 1 as well. So then give me equal to negative 1. So we proved W1 cubic equal to negative 1 means W1 is the cubic root of negative 1. So that's the first one. And the second one, similarly, we proved W2 equals to 1/3 of alpha plus alpha square plus Z3. Okay, I'm going to write this down. So W2 is equals to 1/3 of alpha plus alpha square plus Z3. Alpha plus alpha square plus Z3. So I'm going to do similar proof W2 cubic. See if equal to negative 1. So 1 over 27 same, and alpha plus alpha square. And the W3 we have is negative 2. So we do the cubic of that. So equal to 1 over 27. Alpha plus alpha square would be equals to negative 1. So it become negative 3 cubic. Then they give me negative 1. So we also proved that W2 is a cubic root of negative 1. So let's have a look at the last one. W3 is equals to, let's have a look questions. 1/3 of 1 plus alpha square plus Z1. So 1/3 of 1 plus alpha square plus Z1. And the Z1 we have before was equal to negative 2 alpha plus negative 2 alpha. Negative 2 alpha. And we do that all cubic. And the 1/3 also cubic. So give me 1 over 27. And 1 plus alpha square will be equal to negative alpha, negative 2 alpha cubic. Will be negative 3 alpha cubic will become 1 over 27 times negative 3 cubed will be still negative 27. And alpha cubic is 1 because it's root of unity of 1. So give me negative 1. So now I proved that both W1, W2, and W3 are all the cubic root of negative 1. So that was the original question required. So we're done.